Hey, what's up, Algebra 1? Mr. Catlin here with your homework help for Lesson 10. We're kind of wrapping up this week with writing these quadratic expressions. They're a little bit tougher today because we're adding this coefficient in front. This one's not too bad. I say you can use any method that you want. So if you want to kind of go back and do just the basic diagram method, you can. We talked about doing these today. This one's not that bad. We know that the constant's 5, so the bottom right corner is going to be 5. And we know that the lead coefficient is 2x squared, so we know that's going to be there. The tough part is in the linear term. How are we going to get 7 from this? Because we can't use our what multiplies gives us 5, add to get -7 routine, because the 2 in front makes that a little bit tougher. But we do know that there's only two factors of 5, so one of them's got to be 5 and one of them's got to be 1. And there's really only two ways to get 2 when you multiply, 2x times 1. All right, so really it's a matter of which one goes here. So you can use that method to do that. I'm also going to show you the other method that we learned. Now, honestly, I think this diagram method is probably better for this problem because it's so simple, but I do want to go over it for those that might miss class so you can see how this works, okay? And the method that we learned in class that we can use that's other than this is where we get a lead coefficient of a perfect square. 2 is not a perfect square, but we can make it a perfect square by doubling everything. 4x squared, 14x, and 10. All right, we doubled that, double, double, double. Now, to do that and to actually still be correct, we need to put all of this in a parenthesis bracket and multiply by half, because we distribute that half back out, we're back to where we were. But we're going to focus on this one now that it's been doubled, because this perfect square can be transformed into the quantity of 2x squared. And if we use that same 2x factor for the 14x term, we can break it down into 2x multiplied by 7 and then add 10. Okay, so we still have the same expression, but now the reason why we do this is we want a term that's just squared without a number in front. So we can just put any letter we want here. We've been using n, so we're replacing 2x with n. We're replacing 2x with n, so we're going to n times 7 would be 7n, and then the 10's there. So really this is a version of what we're trying to do with the lead coefficient just being a regular squared 1. And so the half is still there. So we ask ourselves, what can we multiply, get 10, and also have a sum of -7? Well, for that to happen, it's got to be two minuses, because there's no other way we're going to get a positive product and a negative sum with anything other than two negatives. So what can we multiply, get 10, add, get 7? That's 2 and 5. So n minus 2 and n minus 5. That would make that happen, right? And now that we have our factored version of this, we got to remember that our half is still in front. And all of this is equaling 0 throughout. I guess we can write that down. All of this equals 0 as we go. And now that it equals 0, like we can find out what the x-intercepts are if we have it in factored form. But this half needs to get distributed to these. But before we distribute, we need to replace our n's with what they equal. Our n's were replaced with as 2x's, right? So we're going to go back and we're going to put 2x back in the place of n. And we've got 2x minus 5. And which one of these two factors makes more sense to multiply and cut stuff in half? Do I want to cut 2 and 2 in half, or 2 and 5? Well, if I want to keep my numbers whole, then I want to cut the numbers that are divisible by 2 and half and not distribute the half to the other one. So I'm going to choose to distribute the half to these two, which is going to give me, as my final answer, half of 2x is x, half of 2 is 1, and that's not going to change. So it's going to stay 2x minus 5. Now, to prove that that's what we would have gotten over here, right, we can put our 2x here, 2x and 5, and we can put our 1x here, x and 1. But notice that they both had to be negative to make this work. That might have been something you struggled with when you were doing the diagram, because enabled for us to get -7, this has to be negative, and so does this, right? Because the negative times the negative would give us a positive. -5 times x would give us -5x. And -1 times -2x would give us -2x. And those like terms would give us the 7 that we needed in the linear term. So these two factors are the correct version of the factored version of that standard form. And that's two different ways to think about this. You could guess and check to figure those out with the diagram, or you can follow this process of factoring out fractions and changing it to where you just have a single number in front by manipulating the equation the way that you want to. And that's all I got for help on that today. We'll practice this more tomorrow in class, and we'll have like a short quiz, maybe like 3 or 4 problems. Nothing major. All right. We'll see you guys later.